Delighted to be talking to Dr. Jamie Roitman, Associate Professor of Psychology at the University of Illinois at Chicago, site of next year's SFN conference.
That is true.
I saw you this morning, at a press conference about the complicated effects of cannabis on the human brain. And now, in the last year, much has been talked about the effects of cannabis, marijuana, and THC on the adolescent brain. And that's something that was focused on a lot. And you've done some work about that. Can you tell us something?
We have done some work on that. We use rats, which everybody at the press conference today was talking about animal models. In this case, the animal model seems to be a pretty good model. We have really good behavioral paradigms to test working memory, behavioral planning, cognitive control, and we often use an animal model because we can't allocate teenagers into groups and give some groups marijuana and other groups not. And so we can control the dose that the animals are getting. In my work, we have so far controlled the dose that the animals are getting, but we've also done studies with alcohol where we've let them essentially self-administrate, and we give them Jell-O shots, and we get wide ranges of consumption of alcohol.
Let me just get this straight. You give Jell-O shots to lab rats?
We give Jell-O shots to lab rats. And then we can do things like we can look at males and females, and we can look at the ones that consume a lot and the ones that, don't really touch it so much. And then we can get a much, finer grade picture of what's going on in the brain. So as our sort of foray into cannabinoids, we're controlling the dose, and we assign the animals into experimental groups, which we can't do with humans. But the kinds of tests we use with animals, humans perform very, very similarly. The cannabinoid system is very similar in rodents and humans. And so it was an issue that came up, but it is a pretty good translational model. The work that we had done before this was giving adolescent rats cannabinoids through adolescence.
How old is an adolescent rat?
An adolescent rat, a rat hits puberty around day 28. They leave adolescence around 55. By the time they're 70 days old, 70, 75, they're young adults. And when we give them the cannabinoid, we are hitting an age range that corresponds to about 12 to 17. So kind of early adolescence.
Rat adolescence is similar to human adolescence.
Both behaviorally, rats are social animals. They play with their peers. I don't know if they develop identities the way humans develop identities, but the development of the part of the brain that we care about, the prefrontal cortex, it goes through the same order. It just does it on the timescale of days to weeks instead of years.
But both rats and humans possess a piece of biomachinery that I had given very little thought to prior to today: neuronal nets. What, pray tell, is a neuronal net?
A neuronal net is a matrix of proteins that form sort of a lattice around neurons. They mostly form them around these neurons that are inhibitory, and those are the neurons that develop during adolescence.
Inhibitory as opposed to
excitatory. Okay. So an excitatory neuron makes the next cell down the line more excited. It's the putting on the gas. It's the accelerator. It is driving behavior towards some outcome or some action. The inhibitory neurons put the brakes on. So they make the excitatory neurons less likely to fire, less active, and those inhibitory neurons are what develop in the prefrontal cortex during adolescence. They gain greater control over their actions. You gain greater control over your actions because you have this inhibitory control. And so while the connections between neurons are called synapses, and there's in adolescence, in prefrontal cortex, most of the brain has already developed by the time you hit adolescence, but the prefrontal cortex is still developing, which is evident from the behavior of
adolescents. Yes.
Right. So you're pruning. There's a pruning away of synapses, the connections that you don't need, and there's this proliferation of inhibitory synapses. And one of the things that helps stabilize that new structure and connectivity are these perineuronal nets. Peri because they're around neurons, and they literally look like a net.
A reticular
lattice.
Yes. Yeah. And what does marijuana do to the perineural nets of adolescent rats?
We really didn't know. The nets seem to show up during critical periods of development. So they show up in sensory systems when the sensory systems are developing, which is much earlier. They show up in motor systems, and they're in the hippocampus, which is a very plastic part of the brain. It changes in response to experience. And
the hippocampus is also intricately involved in learning and memory.
Absolutely.
Okay.
Intricately involved in learning and memory. So the perineuronal nets start to develop in prefrontal cortex during adolescence.
That's right up here.
It's up here. Yeah.
The grown-up part of your head.
The grown-up part.
Of your brain, yes.
Yeah. And the last to mature. So
generally speaking, it matures around your early 20s.
Early 20s.
Okay.
Yes. And so the nets, we weren't sure if they would develop in a different time span across different sub-regions of prefrontal cortex. That was one thing we wanted to know. We wanted to know if it would be different in male and female animals. And it's been shown that drugs like alcohol and cocaine and opioids can affect net development, that there's less net development, but it hadn't yet been known if they had an effect.
But let me understand.
Cannabinoids had an effect.
So you're saying that these inhibitory, the nets around the cells that produce inhibitory neurotransmitters.
Yes.
The ingestion of marijuana slows the development of these nets?
That's what we seem to see. So the nets are thought to form around the inhibitory interneurons as they're maturing, kind of locking in those new connections during that plasticity, that period of development when things are changing. So it's
so essentially it's making the brakes work properly.
Exactly.
When they're developing,
it's holding the whole system in place when the brakes are developing.
And so, in marijuana in the rats, what does it look like to have? Are there fewer nets?
So we looked at two things. We looked at how many there were, and we looked at how intense they were. And
how intense?
Like how intense. So the way we see the nets is we use antibodies, and some of the antibodies are tagged with a fluorescent tag. And so we are looking at fluorescence, which gives us beautiful pictures. And so we are looking at both where the nets were. So we are staining where
you talk about the strength of the nets is lessened in rats who were exposed to cannabis,
yes.
to THC.
Well, we didn't give them cannabis. We gave them a synthetic cannabinoid.
Okay, synthetic cannabis.
Cannabis is hard to get.
Okay.
For
not if you're in grade school. That's a whole other issue.
Yeah, so I don't know if, you can't get it off the street and then give it to lab.
No.
It's regulated. So we used a synthetic cannabinoid. What we saw was a kind of a normal proliferation, more inhibitory interneurons and more neurons that were surrounded by nets, and those neurons that were surrounded by nets were the inhibitory neurons. In the animals that were getting the cannabinoid, there were fewer. So there were fewer cells that were fewer inhibitory cells and fewer nets, and so the whole system just seemed to be reduced.
The consequence of this, in theory, is that there's a diminished ability to make plans, to resist urges, to
Yes.
control one's behavior.
That's what we think. And so what we think is the cannabinoid use that we're interested in is that 1 to 2 joints a day, not heavy use, but something that's more typical of a teenager. And what we were wondering is if that kind of moderate amount, does that have lasting effects, right? If you're not using the drug really intensely, does that still matter? And does it matter for the part of your brain that you're going to use to figure out, going to college, staying in college, what kind of job you want, making financial decisions, making health decisions, are you at risk for making poor decisions because you haven't allowed your prefrontal cortex to develop normally, and now you're not planning and kind of weighing your options properly as an adult. And so we didn't test that behavior part in this study, but we've tested it in the past and see that cannabinoids given during adolescence affects the choices that the animals make when they're adults.
Now, your specialty is you're associate professor of psychology.
Yes.
So are there behaviorally observable effects of this lack of development of inhibitory neurons, the lack of? Do you see in your marijuana smoking patients? I don't know. I'm asking.
Well, I don't have marijuana smoking patients. But,
of course you don't. I'm sure they don't.
But in our rats, and we haven't done a full. We haven't done all of the behavioral testing that we could, but the kinds of things that we test are things like how long a rat is willing to wait for a big reward, right? Get that kind of, you put one marshmallow on the table and then you say you can have 3 if you wait 5 minutes for it. So we can do a rat version of that.
Okay.
We haven't done that. We've done a rat gambling task to see
rat gambling task?
Yeah, a rat gambling task. So the rat gets to choose between a sugar pellet all the time, or they can get 3 sugar pellets, but it's a gamble. And so we'll change how much of a gamble it is, and we have found that the animals that got cannabinoids during adolescence are more willing to take that gamble. It's not a massive, they haven't lost complete control of their behavior, but there are these biases in their behavior that push their choices to maybe less responsible choices.
Assuming you are correct, assuming that this pans out, then the fact that these neuronal nets are less well formed around the inhibitory neurons in children, adolescents, what is to be done? Have you gotten that far yet?
So we are debating about what to do next, and what we thought we would do was go in and record the activity of the neurons during behavior to see if they were behaving, if the neurons themselves were responding differently. But I think that what we're probably going to do is you can treat the animals with an enzyme that digests the net. And so we make the net go away. And then we see if that kind of opens up this developmental window again to let the inhibitory neurons make the connections that they would have made, and see if we can restore normal function by digesting away that net that developed when the system wasn't functioning properly.
Now I'm confused. I thought that you were saying that the nets didn't develop
They're there. There are fewer neurons and fewer nets developing.
But then, if you make the nets go away, will new ones?
Maybe they'll
grow back.
I see. And proliferate and allow more.
Okay.
Allow
better nets to form.
Right. Better nets to form. Better connections to be the ones that you're locking in. So, if the rat is on a synthetic cannabinoid, and those you have fewer inhibitory interneurons, but you have fewer inhibitory interneurons, but they're making abnormal connections because the drug is on board. And then you have, on those fewer neurons, you have nets. They're locking in this system that is not functioning to its full maturity. The idea is, if you digest them away, do you allow things to proliferate again and to restore the connections that should have been made in the first place? We don't know the answer to that. Yeah. I think that's the first thing to try.
Moving into the area of your personal opinions.
Okay.
I'm of a generation that has thought of weed as a friendly, kindly, lovely, party, and harmless drug. But we see now in states that have legalized and decriminalized a big spike in use among teenagers.
Yeah.
In your opinion, this before we've done the kind of work that you were trying to do. So is it borderline irresponsible to promote the notion of marijuana as a safe recreational substance before people like you and your ilk get a chance to
test it.
dot the I's and cross the T's. Yes.
I think that the decriminalization of marijuana absolutely makes sense. There are other drugs, right? Alcohol is exceptionally harmful, widely used in adolescents. Really,
with similar results in terms of behavior.
With similar results in terms of behavior, but sort of much more severe consequences in the moment. More hospitalizations, more deaths, more accidents, like there are just so many worse things that happen with alcohol. And so, I feel like of our generation, the sound of legalizing pot sounds totally fine. It's harmless. And I have that same perception of it. There are a couple of problems, in my opinion, one of which is that the product that's being sold now is much more potent.
Yes.
And so
we didn't vape back in the rock concerts in the 60s.
Right. And so there's a huge difference in the administration and the intensity of it. And so while I grew up saying...
Because we know it is like 3 to 6% THC.
Right.
This vaping stuff is 80, 90% THC.
Right. And so there wasn't... I don't think there wasn't. We always said there was not really a path to addiction because the potency was much lower, and there really wasn't. So there's habitual use, but it wasn't the same as addiction. I think we don't know the answer on addiction yet, and we're not going to see it until we see really how things play out with the really high potency THC. And what was I thinking? But it's not. The research isn't being done first, like you just said. So the research isn't being done first, and then you make decisions based on the research. In Illinois, it's the legislature that decides which medical conditions qualify you for a medicinal marijuana license. And your doctor doesn't have to prescribe it. They just have to certify that you have that condition. And so it's being done in a very kind of backwards way.
And also the research, as you point out, is being done. The political impetus comes from people who remember a wholly different version of THC.
And if it was that version, I'd have no qualms about it. But I would really not.
But so now we have to let you and people of your ilk just go on and do your research as our teenagers continue to do it.
Yeah, I have 4 teenagers. I have kids that range from 15 to 19.
There was some controversy among the panel today on THC about the difficulty to get approval for human research on THC and cannabinoids.
Yes.
And what's your perception of that?
So I was just talking to my grad student about this as well. It's difficult to get THC to do research, and it's difficult to get the FDA license, and it's difficult to get the THC itself. There's a source. There may be 2 sources now. There are very few NIH-approved sources of THC. So it's not, the drug itself is much more widely available than the research drug, and it's been legalized medicinally without those clinical trials that most drugs have to go through. And so that part of the controversy I think is accurate, right? There are lots of drugs that are difficult to get because they're proprietary and pharmaceutical companies don't tell you what they're doing. But they are going through clinical trials. It's more difficult to do THC research.
And that's because it's still a Class A.
It's still,
Class 1. The federal government considers it a Class 1 drug.
And so the federal regulations make it difficult. It can be done. Some of it is being done. It's not being done nearly as widespread. There's a ton of research on cocaine. It's not that it's easy to get cocaine for research purposes, but you can get a license to do research on cocaine. There is much more research out there on cocaine, not in human subjects, but in the animal subject world. And so it's my perception is that it is much harder to do. And in Illinois, where we have the medicinal system, there are licenses. The patients can get licenses, but when it was first rolled out, and there was talk that we would need research licenses, but there wasn't the infrastructure put in for that. I hope there is. I think that would make life much easier. I would love to be able to, right, so I give rats Jello shots. I would love to be able to go to a dispensary with a research license and get edibles and just pop those in a rat's cage and let them have at what humans are having. It'd be fun.
Well, I for one hope you get that opportunity soon, and I hope that the information is very useful. Thank you so much for your time,
Thank
Dr.
you.
Jamie Roitman, Associate Professor of Psychology at the University of Illinois at Chicago. Yay, homie! Thank you very much.
Thank you.